Alright, my name is Ryan and welcome back to another wacky physics video. Today we have this problem, and it starts us off with a 60 kilogram woman that is in an elevator accelerating at 0.8 meters per second squared. Now the problem wants us to draw a free body diagram for her and calculate all forces acting on her. Then it wants us to draw a free body diagram for the elevator of a mass 200 kilograms and just calculate all forces on it, meaning the elevator, ultimately determining the tension in the rope. And it gives us this illustration here of the lady in the elevator with the tension pulling up, so it's accelerating upward. And I guess we'll just start off by drawing the free body diagram for the lady and calculating the forces acting on her. So for the lady, the only forces really acting on her are going to be the force of gravity that's pulling her down, and then the normal force, or the force from the elevator that's pushing her up. And since she's being pushed up, the normal force, or the force of the elevator pushing her up, is going to be greater than the force of gravity. And I guess we can start off by calculating the force of gravity. So the force of gravity is going to be pretty simple to calculate. It's just going to be equal to the mass times acceleration, specifically her mass times gravity's acceleration, is going to be equal to 60 times 9.8, which is going to be equal to 588 newtons. Now for this normal force, which I'm calling here, but it's actually just going to be the force of the elevator pulling her up. That's going to be a little bit trickier because she's going upwards. That is implied that she's also counter accelerating, like the 9.8 from the gravity pulling her down. So we have to take that into account. Since we don't outright know what this force is, we can figure it out, like I said, by figuring out this acceleration. It's not going to be just 0.8 by itself, because it's also canceling out this 9.8 effect here of gravity. So we have to take that into account and just add them together. Now that we have that acceleration, we can just say force is equal to mass times our new acceleration, which is 10.6. 60 times 10.6 is equal to 636 newtons. And this makes sense since this force that's pushing her up is greater than the force of gravity pulling her down. She's going to be accelerating upward, which is the case. And that's about all the work you need to do for the lady. Very simple. This is an interesting concept that might be difficult to understand at first, but I think with a couple repetitions you would be able to get it. Now for the elevator, it's a little more complicated. We have the tension of the rope pulling it upward. We also have the force of gravity pulling it down from the elevator itself, because it also has a mass. And then we also have the lady herself pulling down, pushing the elevator down too. But we don't have to include this force right here, because this force is only acting on the lady, not the elevator. So what our force diagram ends up looking like is just this tension force, because it's pulling it up, the force of gravity pulling the elevator down, and the force of gravity from the lady pulling the elevator down. The force of gravity from the lady we can just get from the previous problem. And the force of gravity for the elevator is going to be equal to the mass of the elevator, which is 200 times 9.8, which is 1960. And then with these two equations, we can set up like a F-net equation, right? F-net is going to be equal to the tension minus the force of gravity, which is pulling it down, so it's going to be negative, minus the force of gravity from the lady, which is going to be down, which is why it's negative. And we plug in our knowns. We know the total mass is going to be 200 plus 60, 260. We know the acceleration of the whole system is going to be 0.8 meters per second. And we don't know tension, but we do know the force of gravity on the elevator, which is 1960, and we do know the force of gravity from the lady. We have all our knowns, we plug them in, and we just solve for t, and we get that t is equal to 2,756. And that's about it for this problem. I hope you guys understood this. This is an interesting problem. If you enjoyed this, make sure to like, favorite, and subscribe, and I will see you in the next Wacky Physics video. Thank you.